This is part number 7, video number 7 in the series of video tutorials for constructing our target application. This is also the second one in stage 3. In the previous video, we got as far as step 8 in the guide for stage 3, and we attached the functions to the replay button and the exit button. The only way we will be able to test those is once the game is done. Of course, the exit button will work only when we actually compile it to an application, and then we'll see it quit. And the replay button will be able to see if it works. Actually, there's a way to see if it works. Actually, if I play right now and I artificially show the replay button, initially it's supposed to be hidden, but let's pretend that it's shown. The way I will be able to know if the replay button works is if I press it, will it generate a new target? And it did, which means, it reloaded the scene. Good. That means the replay button is working. And then we can, of course, always stop when you play. Not pause, but stop. And now we can actually continue. Step number 9. There's a script called TriggerOnKey. You got the code for that in your module. You're going to, just like we did before, copy all the code, replacing the code in TriggerOnKey. So first of all, let's find TriggerOnKey. It should be in your scripts. If you remember, that's the script. Let's disable the replay button. That's the script that's attached to the bullet, the missile. So this is the script that's going to make it rotate when we press keys left and right, and then be launched forward. I'm going to open it. It's going to open in my default code editor. Different installations of Unity might have different code editors, but in the end, it's the same code. Right now it has nothing but the shell of the script. I'm going to clear that. I've already logged into my D2L, found under module 7 the section called codes to copy paste, found code for TriggerOnKey, and I'm going to highlight. This is a shorter script than the one we did before. Actually, pretty short. As long as I copy everything from the first comment to the last curly bracket end class, copy, go to here, paste. If I started from line 1, then the end should be around line 33 with a few even like empty lines in between. So it's really not a long script. And of course, save in whatever your code editor is. First of all, before we even go into the structure of the script, it declares one of the public fields it declares is a float called rot speed, which stands for rotation speed. It's a field, and that's the degrees per it's degrees per second that it would rotate. So, in order for that to actually work, I'm going to go back to Unity. First of all, I'm going to see that it compiles the script and it doesn't show any errors. Console, if there are any warnings, I clear them. But in the prefab, this is going to tell us to do that in the next step anyway. In the prefab called bullet container, there's now a script with one public field, rotation speed. As long as it says 0, it will never rotate. So I'll change it to 20. What does 20 mean? It means that it's 20 degrees per second if I keep holding the key. So now if I play, I should see the bullet. Now pressing the left or right arrows, see how it's rotating very slow, like 20 degrees every second, or the other way. And when I think I'm aimed at the right place, pressing the key B, we're going to see that in the script, will activate. I can even show that. Here's the bullet container clone, and here is its constant force. I want you to look at this checkbox when I press B. See how it was activated, and it flies forward. Nothing else works because we haven't scripted what the wall does or the target does. So those are the main two jobs of this script: to enable the rotation of the bullet and to make it fly forward on keyboard interaction. Let's see how that works. Back to the code. The only library we need is the Unity engine. We always make sure that the name of the main public class TriggerOnKey matches the name of the file. And this, as we always do, we declare our public fields first. Rot speed, the one we just used, is the only one. It's a floating number, which means we can have decimal fractions. Then everything is within the function or the method update. And if you remember, update is called once per frame. The default frame rate of Unity is 50. So everything it says here between update and end update will keep getting executed 50 times per second. The first thing it checks is, did I press the key down? If input.getKeyDown, key code B, it's pretty self-explanatory. Input is a class within the Unity engine. Within that, there's a function called getKeyDown and the key code B, if the user pressed B during that particular frame. If it did, the get component of this object, this is attached to the bullet, it says, hey, this bullet has a component, it's called constant force. Make it enabled, true, and that's what launches it forward. That's it. If, and the second question asks, well, what if horizontal is smaller than 0? So this requires a little bit of an explanation. If you remember, at the beginning of this stage, we changed the input to both, which means it can use both keyboard interaction and later on, like a game controller and so on, which is the new interaction. So if we go to Edit and in Unity, Edit, Project Settings, and we go to Input Manager, and we unfold axes, we can see that it has a bunch of them, but the one we need is called horizontal. If I open horizontal, you can see that it's already attached to the left and right arrows, the A and the D key for what we call WASD, and it can also be used from all joysticks. What it will do is, it has a value of 0 to -1. When it's not being held, when the key is not pressed, its value is 0. When I press the key, it goes to -1. Why -1? It reduces to -1 because to indicate that it's left. The other one, the right, will have a value of 0 to +1. In other words, if horizontal is bigger than 0, I'm pressing the right key. If horizontal is smaller than 0, I'm pressing the left key. And that's exactly what the script is asking. It's really asking if horizontal is smaller than 0, that means user pressed the left key or the A arrow. If it does, I want this object to transform, rotate. Vector 3 down is just a shortcut for saying, I know that there's 3 vectors, X, Y, and Z, but we're going to ignore X and Z and concentrate on the Y because it's up and down. Now, down means counterclockwise. As you will see on the other one, up means clockwise. So vector 3 dot down means Y axis counterclockwise. That's how it's going to rotate. How much will it rotate? My rotation speed, we typed 20, but it's 20 degrees per second, and there's 50 frames per second. Time.delta time is the time of 1 frame. In other words, it goes and calculates by itself, if I need to rotate 20 degrees per second, then every frame is going to be a 50th of that. And that would change also if I ever change the frame rate. So every frame will be a 50th of what I want to rotate per second. And overall, if I keep holding it per second, it'll rotate 20 degrees, 30 degrees, whatever I type in there. When I let go, it no longer rotates. Same thing. If horizontal is bigger than 0, I got a positive value. That means that the user pressed the right arrow or the D key. And it does exactly the same thing. The only thing that's different here is the word up or down. Up just simply means it'll start rotating clockwise. How much? The duration of this frame, or the fraction that represents the time out of a second, which is this frame, times Roth speed. A 50th of the Roth speed. Again, don't count on the fact that it's always a 50th, because, for instance, in virtual reality, it will be 72 frames per second. So it knows the delta time. Delta means difference. It's the difference between this time and the frame before. So in other words, one frame. End update, which started here, and end class. That's it for this script. Again, the way to test it would be to go back to Unity, play, get one of these, see that I can rotate, and see that I can launch. One more comment I'm going to make. Of course, in order to get another, right now, in order to get another bullet, I will have to stop and play again. Something that has to do with game design. If I go back to the bullet and I go, what will happen if I do a rotation speed that's much faster or much slower? For instance, if we do a rotation speed of, instead of 20, I will make it 100. I'll exaggerate. What do you think? Will it make it the game easier or harder? Right now, it rotates 100 degrees as long as I hold it. It seems cool, but it's actually harder because it's harder to stop exactly at the right angle. So actually, smaller values, let's say 10, will make it rotate really slow, but will make it much easier to aim. See, right now it's... So this is one of the things that we do. We will talk about it in class as game designers to, after the game is done, to test it with real users to see what would make the game just easy enough, just hard enough to be, entertaining. This will be the end of this part of the tutorial. In the next part of the tutorial, we will engage the next script.